Okay, so we're graphing sine and cosine. Okay, so again, if you're following what I'm asking you to do, so the first thing I'm going to do is write the equation here with all of the transformations. Okay, so having this here will tell me what each one of these numbers is going to do to my function. So k, that is my vertical shift. It also tells me where my center line is. So my center line has been moved to -1, which means it's been shifted down 1. This is my amplitude. So my amplitude is now 3. It's been increased from 1 to 3, because if there's no number there, then it's 1. So that is my vertical stretch. So it's going to be taller than the original function. Then there is no change in period. So my period is still 2 pi. So there's no horizontal stretch or compression. This is my horizontal shift. Okay? And since it's negative, we're going to the right. And how far are we going? 2 pi. Okay? So again, start with our parent function. So here's my cosine. Cosine's parent function looks like this. These values coming from the unit circle. If you go to the unit circle and you look at the degree 0, radian 0, cosine is 1 because it's the x part. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. At 2 pi, it's back at 1. Okay? So if I'm doing transformations, again, we do any kind of stretch or compression first. Since I have no change in period, I don't have to do a horizontal stretch or compression. So the next one is going to be my vertical stretch or compression, which is my amplitude. My amplitude is now 3. So instead of it going up to 1 and down to -1, it's going to be stretched to 3 and to -3. Zeros are in the same place. So here is your first transformation. This is my vertical stretch. Okay, that's this number right here. And that's why I have you guys use different colors for each one, so that you go back and you go, okay, well, the purple one, that was that number. That's what happened when the purple one. Okay. So next, I'm going to do this part in blue. So what that's going to do is shift everything 2 pi to the right. So where this started at 0 and ended at 2 pi, we're going to take this whole thing and go move it over 2 pi. So now it's going to start at 2 pi and end at 4 pi. So we're just going to move all of these points over. So this point is going to move to here. This 0 is going to move to here. Pi plus 2 pi is 3 pi. This is here, and 2 pi plus 2 pi is 4 pi. So this is my new function. And it almost looks like I just continued the cosine out. And then our last transformation that we need to do, that's this -1, and that is a vertical shift down 1, which means all of my values are just going to be moved down 1. So this one goes down here, 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 and then this one goes down there. And then again, you connect your dots, and that is your transform function. And again, does it match all of my information? Well, here's my center line, -1. My amplitude's 3. So if I go up 3 from here, 1, 2, 3, and down 3, 1, 2, 3. Is that where my maximums and minimums occur? Sure does. If you look there and there. In the notes, there were also two equations if you wanted to use that look like this that might help. It said if you want to find your starting and stopping spot, you could use bx minus h equals 0 and bx minus h equals 2 pi. And then you plug this in here. And basically that'll give you where it starts. So this would be x minus 2 pi equals 0, which means x equals 2 pi. That's where our wave is starting. And this one would be x minus 2 pi equals 2 pi, and you move it over and you get x equals 4 pi. That means our wave is starting at 2 pi, ending at 4 pi. So that is another way to figure out where it begins and where it ends. Okay?